architects really seem to be really laid back, in my opinion, as a community, as professions, that they really don't want to embrace technology yet. No, like it's not like IT. You are speaking a language which only architects understand, and your client is never going to be fellow architect. To uske baad to you have to get serious about it, no? You have to do 5 projects with it, then you will come to know that where and how can it be applied. Knowing Rhino and Grasshopper as basics is very good, but it's just a start. Computation is equal to Rhino and Grasshopper. I know these things, so I should be able to do great, no? So those who are really aspiring to think of urban design and urban planning after your first degree or some work experience or whatever, you can always think of it in terms of cutting edge technology, because it exists and it is already evolved.
A masterclass titled Craft the Unimaginable, Generative Design and Digital Fabrication by Urvi Sheth. Now, I'd like to welcome Urvi Sheth, the founder of Craft Quest, an architecture and art firm supported by Craft Quest Workshop. Welcome, ma'am.
Good evening, everyone, and thank you for being here. I expected very little crowd because this is a subject which not a lot of people are still either able to understand it or appreciate it or take it forward. So thank you so much. I see some familiar faces around for quite a long time. And thank you so much for the wonderful introduction. Little bit more I could say about myself, saying the journey, because before I get into the details of what you want to know, as she rightly said, I have founded a firm called Craft Quest, and you will see some work on the website. I have established it in 2011 sometime. Since that till today, we have been working on projects specifically in this direction. Like every project of ours speaks something or the other about computation, digital fabrication, and crafted piece. So each project is also very well thought while taking it on board, because if the project didn't have that scope, I had denied that okay, if it's a regular modern, postmodern architecture somebody's expecting, or interior design which is seen several times on photos and magazines, if somebody comes with that kind of Pinteresting that I want something like this, that's not my client. So again, I have been in a position to make these choices. Alongside, I have been director of workshops at CEPT between 2014 till 23, which was based on my passion of making. So I'm a person who is really passionate about making. Whatever I design, I really want to see it through till it's made, it's come to life in physical form. So digital architecture per se, or computation, also talks about a phase where you can leave it as a 3-dimensional render or a video or a digital content. But most of the time, that's not my interest, because I feel until it's tested through time to physicalities and to the real life, it's not done. It could be a beautiful output, it could be a beautiful product, but it's still not tested for its materiality, time, etc. So until it's built, because we also had a session today about unbuilt and so on. So I thought, yeah, I mean, I'm a person who falls in this zone where I really want to see things built, because I really like to make. Except we had a lot of little workshops when I joined, which were there for forever, I guess. Architecture workshop was there since the day of when architecture faculty was built, because it was a site office and then converted into a workshop, etc. And then there were a few that came along in time. My task there was to sort of consolidate all these little things on campus and put it under a roof, under one workshop that you see now opposite Southgate. So I was part of the design process. That building is designed by Gurdev Singh, not Gurjeet Singh, Gurdev Singh from Baroda. And I was sort of collaborating with him, demanding as a client that my workshop should have this. And he was the one who designed. So we saw the workshop building coming up, and then my task was to put machines in it, to bring people in it, to train people in it. Everything was done by 2022. After that, this also took care of COVID and COVID period and whatnot. So minus that, 2023, I am part of this international organization which is called Computer-Aided Architecture Design Research in Asia. So this means Asia Pacific. I was secretary then, and now I am part of award committee as chair. Since I was associated with them for a long time and other such organizations, there are 5 of them across the world, which also talks about computer-aided design and architecture since I think 1990s, when some of you might have been born, or the year of, so it's as old as that. And hence I felt very strongly in 2001 that we should bring this conference to Ahmedabad to benefit the Indian students and academics. So I organized CAADRIA 2023 at CEPT campus. Why am I saying all this is not to flaunt around who I am, but it is to probably add to this lecture, because you seem to be serious or curious about this field. So what is the scope academically? What is the scope professionally? What can you do? What can you not do with the given resources? No resources, zero resources, etc. I'm going to talk about all of it. So let's begin. This sounds very pessimist, but it's a fact. Can somebody read it loud, because it's too close to me? Please.
Architects tend to be late in embracing technological change. Mario Capo.
Precisely. It's not me, but I strongly agree with this. And probably all of you are also still facing that challenge. This comes from the fact, can you go to next please? That Charles Jackson has studied the history of architecture and the movement. Like this is like a real academic class. I'm not here to show you my work and say this project I did like this and this like that and there's the story. Yes, there is. It will come if I come to you as a keynote speaker, but right now I'm here to sort of give you an overview of what computation is and what it means in architecture and how it started. So architects really seem to be really laid back, in my opinion, as a community, as professions, that they really don't want to embrace technology yet. No, like it's not like IT. It's not like engineering. It comes that, oh, when you are out of no choice, then you start catching up. So that's what happened, and somebody has really mapped this. Charles Jackson has studied and mapped that who did what in time from let's say 90s, because as I said, the whole thing about computation, digital fabrication, digital movement started in 90s already. And you guys will find this image everywhere on internet. So somebody who is really interested in studying this, please go through it. It's very informative. I have plotted it here so that you can have these pointers on. But that includes the heroes from modernism, postmodernism, then deconstructionism. These are all the movements in time, right? Like I'm not talking about the era before. But why this happened had a reason. Why there was a rebel against it, had a reason. Like modernism came due to industrial revolution. Then postmodernism came because of just rebel. There was no good reason to really have that movement, but people were, I think, bored of too much simplicity. Then came deconstructionism, which again had its own masters who argued their own theories. And then we are talking about computation, which was never defined as computation. And there are various terminologies floating around known as computation. So we are talking about things which are progressing through time and developing. And hence, like she said several things about my lecture, generative architecture, digital fabrication, this, that. But all of it is in the end advancements in technology involved in architecture. So what happens is that any change that comes, that change comes very quickly in language. First thing is language, which adopts these changes very fast, right? Anything that will, it is wording. It requires minimum time and maximum reach in the shortest time. Then it comes in art. When it comes in art, the scale is small. So you can experiment, you can explore, you can try out things, and without any obligations to the function. So you really don't have any function to cater to, right? So you can have an idea, you can, art has a lot of freedom than architecture or interior design, and the scales are normally smaller than that, which of course art can be, when you think of public art, the scales are much bigger, but we're talking about entire range where actually function doesn't come in the picture. Then it comes to the product. Products are, again, they are a scale, but it has a function to cater. When you design a product, it should do the job it is required to do. Otherwise, it will fail. If you make something very beautiful looking or feeling or aesthetically pleasant and wow, but if it doesn't do its job, it won't sustain in the market. So that's what I'm talking about, product. After that, it comes to interior design, then architecture, and then in the end to urban level as planning or urban planning, urban design, which I also don't understand very well because it's a scale which I am never trained for. So my knowledge stops till architecture. So whatever I'm going to talk today will be limited to that. However, computation is not limited to that. So those who are really aspiring to think of urban design and urban planning after your first degree or some work experience or whatever, you can always think of it in terms of cutting edge technology because it exists and it is already evolved. So when we talk about computation, we are talking about three things, three heads. It's straight there. We are talking about design, we are talking about optimization, and we are talking about making of it. So digital fabrication, right? When we talk about design, there are various logics. There's generative design, there is emerging technologies, there is AI, there is, I mean, you name it and you will have various options as design tools. Now, these are your design concepts or design tools or design ideas or whatever for concept design and development. But it has nothing to do with optimization. Optimization is a science in itself, right? When you want to optimize something, what does optimization mean? Optimization would mean to optimize a structure or a material or something that you want to minimize the use of. So what can you think about it? Design will talk about your maybe planning, layout, aesthetics, whereas optimization will talk about pure performance. So there is a big difference. Often we mix it. then we confuse ourselves with, and then we try to find a way that which one are we dealing with right now. We want to design, let's say, for we want to design a building which is performing best for the daylight. Now, is this coming as a design brief, or are you optimizing something? So when these kind of ideas come, it's really confusing. So one has to really think, where are you starting your project? Or you are designing something in that sense. In any which ways, when you talk of computation, by default, digital fabrication will come into picture. It is not that the perceived notion of computation, which generally Google will throw you 10,000 image of complex geometries, hence has to be digitally fabricated. But somewhere or the other, if you do this, your workflow will be simpler, because you've designed something which has a data which can be used for production. May it be simpler, may it be straightforward, but still it will be faster. So it will save your time. That's exactly why we are talking about digital fabrication. And it's not because your designs are complex necessarily. So these are the three elements, in my opinion, which involves into computation, and within each of these heads you will find many branches. So you see, the subject is really, really vast. I don't think I can even tell you the length and breadth of it in 1 hour here. I'm trying to summarize and get it simpler as much as you can take it. Next, please. Computational design process, again, which we talk about, has design process, design methodology, and design tools. So we are only focusing on the first part of the previous slide, which we are saying design. We've not got anywhere into production. So what all do you need for design? You have design process which talks about parametric or associative modeling. Now, how is this different from BIM? Because I'm sure you all work in Revit now, and or you are trained to do so because you will have to use it. Now, building information model, and which is called BIM, and parametric model or associative model, what does it mean? Can anyone answer that?
Building information modeling is basically, it's not like you're not just creating a 3D simulation like how you do it in SketchUp or other regular 3D modeling softwares. A BIM model is more like an intelligent model of sorts, where you fed all the information. You're not just like putting up a door or a window. You're actually telling the software, what dimension you wanted, what material you wanted, etc. So it kind of helps like that. Versus parametric modeling is more like it depends on various parameters, and it gives you a geometry based on those parameters that you give it.
Partly true. What you said is all true, but it's incomplete truth. So I am saying partly true. What she said is precisely correct, that in a building information model, you are required to feed in all the information in terms of material, in terms of dimensions, this, that. Once your model is ready, it's a data that is used for coordination of a project. So you also feed in not only door, windows, flooring, paint, this, that, but you also feed in your services, your electrical wiring, or all kinds of engineering data, from plumbing to drainage to everything that you can imagine in a building can be fed in that model. And hence it becomes a consolidated single data, which ideally claims to replace your working models or working drawings. So all these hand drawings that you do, hand drawings, as in even if you do it on AutoCAD, is hand drawing, because you are drawing line by line. Nobody is giving you a generated drawing, right? So there is a difference between what you are saying hand drawing, like literally sketching with pen, pencil, or using any software, which you have just replaced your drafting boards and pen and paper with a software. In my mind and in my terminology, it's still hand drawn, because you are drawing it, right? You are not extracting a data which is ready made and you are brushing up and pushing out. So there is a difference. Likewise, so building information model remains very, very effective as a consolidated data. It is still not a generative model, because generative model or parametric model or associative model is used before that stage. Building information model will be used when your design is ready. You want to share it with various consultants. Everybody will put in their data. You can do a clash detection analysis on it, and you can tell each other that your pipe is in my way and you can't do this hole, and you cannot sort of share data that every architect, engineer and contractor should have. So once you have all these clash detections sorted, you can give the same model to your contractor, and he should be in a capacity to read this model so that there is no conflict on site, and ideally it should save everyone's time, because contractor knows where to go, unlike you are reading from 2D drawings and trying to figure out ki kaun si height pe hai, where is it coming, and no, three-dimensional, you have to read it in two-dimensional only. This is a model, so you can rotate, you can zoom in, you can do whatever and check. It's a real-time data, and it's a real-time data which everyone is allowed to edit also. So that's the data which is helpful for coordination and execution. But what about design? So you have to step back. That's when you are talking about parametric and associative modeling. So what does this do? Parametric, everybody knows, I think. That's why you are all here in this seminar hall. Can anyone define or want to say something?
For parametric and associative modeling, so associative in what sense? So let's say if I can talk about this particular building that we are sitting in, we all know that Corbusier developed the modular system where there are some set of rules for proportioning this building. So how the heights are divided, how the elements are divided. So there is a proportion that does the first division of this building. So let's say this building is designed using the 9 square grid. So that is one part. The columns stand on that grid. So how column is connected to the grid, how the entire plot, the placing of this building in elevation, how the heights are divided. So associative means that on one base idea, all of the elements are placed.
Again, whatever you said about this building is true, and it does help explain the associative modeling. I will take it forward from there, that ideally it's the association of the smallest element of your design with the global output of your design. Meaning to say that smallest element of design collectively coming together, becoming a whole as a building. So you are talking about parts and you are talking about whole. So when your parts are little and that is contributing to a whole, if you change one part, it is going to affect the neighbors in both the directions, 2-dimension and 3-dimension. So when you change one smallest thing in your model, it has an effect to your global design or global output. Now this can be, like he said, if we take this example, your grid and its columns, and versus that there is a facade system and there are rooms in it. Now proportionally, floor to floor, there is a facade. So if you change the floor height, you shouldn't be ideally sitting and redrawing these parts, dividing equal and do all the labor. The association of your external fins to which is associated to floor dimension, if you increased, it should automatically increase, and if you decrease, it should automatically decrease. Likewise, if you changed one column, it should have a global effect. No? If you want to remove one column and you say, okay, I don't want this column, what's the effect on the entire structure? Space wise, it will show that the column is gone and the space is free, but structurally the spans of the beams have become bigger, and it has to be have a greater depth, or it has to be designed in some other way. So this association, which in a simpler geometry, you've taken a fundamental example, so it's easy to understand. But when you talk about rather complex examples, which let's say in airport or in a public building, which are large in scales, and there are also repetitive and modulating elements. If you see, airport would have modulating elements, but they are not identical. They will change in scale, they will change in size, and depending on the requirement of the floor space, you will see a lot of variations of the same thing. How do you create those variations? We have been creating that traditionally as well, so there is no way I am saying that it's not possible. Wonderful airports have been done before. But what happens if you have computation by your side? Lot of your labor is reduced. You get multiple options in a shorter duration to visualize. For example, this is a standard example I give also in the class or studio where I teach, that if I asked you to draw 20 sketches, she's smiling, how many times will you really come up with 20 sketches? And how long does it take to make 20 options, conceptual options of a same design brief? And if you are using computation, how many options can you create? Now, in the first step, you cannot question whether all of them are logical, because they won't be. They won't be. I'm claiming that all of them will not be logical. That's why you will have some selection criteria, or you will have some understanding on it that this is the logic based on which this is logical and this is illogical. So it goes like that. However, coming back to the fact that you will save a lot of time in creating variations for customized desired outputs. That's the thing with parametric and associative modeling. What requires to do so is there is real-time simulation, there is building information model, there is rapid prototyping. That's the methodology it goes through, right? And then what are the tools required to perform those steps? So you know there are various softwares now, much evolved than what I have listed here. Then you have more sophisticated fabrication technologies available. Now, you can have a separate discussion at the end of this class that whether we have it or not, or whether can we do it or not, and all these kinds of questions come standard with this discussion of computation. Next, please. All right, I think this is what we have discussed, but if you want to get into further details of technical terms, we call it, there is a design scheme, there is a means of creating variations, there's a means of selecting desirable outputs, which is what I just explained, and then you create mutations and crossovers. These sound like very biological terms, but I don't know other method of describing them in architecture, so this has remained our vocabulary. So you see, when you talk about computation and when you talk about designing through this approach, it's an approach, you will automatically start going out of architecture rigid boundaries. You will start blurring the boundaries, and you will end up working with many other professionals as interdisciplinary. Engineers are default required for architecture, that's like taken truth, but you will start working with other professionals as well to even generate your concepts. And those are the steps normally performed if you want to go through this design process. It's not very different from what we used to do earlier, but it's claimed to have an iterative process. And I feel even earlier we had iterative process. Only difference is that during those iterations, we did not take into account, or most of the time, machine tolerances or the fabrication tolerances, or sometimes certain challenges that comes on site which we don't know. Here, because you have analyzed your data of site through through digital information, you already have that imbibed information in your design model, which will constantly trigger, like your seat belt in the car, that this is the alarm, take care of it first, otherwise you will come back in the end and then you will have to change a hell lot of things afterwards. So it's iterative process, and then you have your data ready for production. You don't have to sit and make a separate set of drawings or data to communicate with your site engineer or contractor. So you can extract from that and you can communicate. Contractor being smart, you can directly send your BIM model and you are done. You can take another project. Next, please. Now, I'm going to talk a little bit in detail about generative architecture only. Because of the time constraint, I don't think I can talk all of it. But if you guys are interested in something else, you can ask me questions and I can answer. So why generative architecture? Now this one why will, and it should actually make you think why for every time you choose your path. Why AI, or why this, or why emergent, or why whichever. This is just rolling a path that why are you doing this? Why this approach? Because it doesn't come baseless. Next, please. So, as I said, there are three basic aspects listed there. That is aesthetics, it's performance, and it's social. Now, I don't think our built environment goes beyond this in any case. So it takes care of all three of them beautifully. And hence, how should you do it and what would you do it with this approach and with these tools is a question. So the detailed explanation of it says that you can recognize, measure, and simulate the complexity. You can analyze and appreciate the underlying logic and rationality. Reveal the complex order of seemingly chaotic patterns. Valid at all scales. Its strength is directly related to the scale. So it means that it is most powerful when it is most biggest or complex. Because if you are questioned sometimes that if you do a sculpture, what complexity of a sculpture is it involving? Though it might be tiny, but if it is complex, then it is most powerful. What complexity of program are you dealing with? If it is more complex, you see the effect of it most in that sense most. Like if you're dealing with a residence or a housing, you will see its strength in housing more than a residence. Because in residence, you are dealing with what? At the max 4 bedroom, hall, kitchen, lounge, and a few toilets. Whereas if you're doing a housing, you also will end up making layouts and services. And it's not, then suddenly the program is much bigger than single unit. Or in housing, you will say, okay, this is a typology, second typology, third typology, and its layout. So more complex it is, more performative, I would say, this is. Its maximum emphasis is on continuous differentiation, visual amplification of differentiated logic, aesthetic elegance, and ordered complexity. Now, all these are very technical. If somebody wants to understand in detail right now, I will elaborate. Or should we go through the examples which will help you visualize these things better? How shall we do it? All right. Okay, so this list we can refer in the end as well, but I will quickly read through because these are the reasons why are we doing this. And if one wants to understand what is the strength, so offers an associated system of correlation, does not impose any compulsory adaptation, non-standard designs, means specificity in architecture. Now this is important because at times in a hurry or in whatever pressure, we end up making very stamped sort of designs. Now this can come as a pressure from the client, or it can come as a pressure from peers, or it can even come as a pressure from the images that you see on internet, which is showing you this is beautiful and this is ugly. So your perception of beauty is also coming as a pressure, which you don't need to ideally. That you can specify everything what you think is correct in the model and it will generate accordingly. You're talking about mass customization and not mass production. Now, this is a big debate and big conversation in the industry, because industry today is still based on industrial revolution and the result of World War II. We have started making mass produced elements. So we say, okay, everything has to be mass produced, hence cheaper, and hence how can you make it cheaper and mass produced? This is what we are talking. But with the technology on our side, with the, I would say this is what? Technological revolution. After industrial revolution, this is the technological revolution. It has allowed us to think about mass customization, because you can produce each piece customized. You have the tools, you have the energy, you have the material, you have everything available, and you are no longer in the race of producing it minimal and standard, because you have to cater to so many housing, or you have to see the whole idea of mass production had started because in bombing and in World War, cities and cities were destroyed. So there was a need of housing, urgent. There was a need of infrastructure, urgent. There was need of everything urgent, and they had to minimize the time. And hence everything was mass produced. How can you quickly do things? We are not in the same age anymore. After 75 years of freedom, or 78 years of freedom, and so many years of World War passing, we are still talking about the same thing in the industry. That should be questioned. That are we in the same boat, or are we somewhere beyond that? Have we evolved? Have we passed that bad phase and we are in a state where luxury is talked about, and you're talking about high-end everything, and then you are still producing mass-produced things and putting things in the buildings that wherever it's required? Can we make it better? And it is not only in terms of aesthetics. It's also to make it performative. Because in the process of making it standard, we kind of removed all these aspects of how can you make building perform without air condition, or how can you make building perform with minimum resources. Because they were standardized, now there is a problem. So the mass customization is very important, and it is one of the biggest contribution of technology, that you can really produce things of your desire. Innovation in the material use, optimization, integrated, minimize construction period. Now that's another level of discussion, which I don't think we are having today, some other day. So from all that, we are taking examples of design integration, because this is going to show you various examples of great architects, performed buildings, tried and tested. You would all get convinced about it that yes, this exists. So that's why I have chosen that, and let's go forward. Move forward. So some of these you would be able to relate. How many of you know whose work is this? Please raise your hand. Oh my God. Yeah, that's Fry Auto. Fry Otto is known to be an architect who has been practicing computation without computers in place, without even the advent of computers. So in those days, it was called form finding. So he used the methods, the physical methods, to explore various forms which are behaving along the nature and along the forces or the structural line of forces. So every structure that you see here, there is no added structure design required. It's coming out of the natural lines of force, the structure that it requires to be. And next, please. Hence, these are very popular prototypes. And I think next, please. Okay, go back. There is also a very big difference between a prototype and a model. So I think what you do in architecture training is all models, because you design first and then you make a miniature of it, and it's called maquette in the art world, and in architecture we call it model. But prototypes are different. Prototypes are true test of your design. It really shows you if your structural behavior is correct or not. It shows you what you have designed is going to function or not. When you make model, you don't get these kind of feedback. It just shows you your three-dimensional geometry in a physical form in a smaller scale, right? Whereas prototypes don't do that. Prototypes made at various scales. They are also done at various scales. It could be a miniature. It could be scale like 1:1. But it always imbibes the behavior, structural behavior, performance behavior of what it is prototyped for. Next, please. This is another great gentleman. Sagrada Familia, how many of you have visited? Nice. And how was your experience? So imagine single genius mind, Antonio Gaudi. Again, he is an architect of an era where computers didn't exist, and it was purely one person's mind designing and controlling everything. Now, what has happened over time is that building is under construction for 300 years or maybe more now. But unfortunately, our lifespan is not 300 years. We die nowadays at 60, 70. So whatever he had designed, he had made prototypes of it in plaster of Paris and such. In World War II, all of it got destroyed as well. So that's why the building got remained incomplete for many, many years, because nobody else could really decipher what happened and what this building wants to be as complete. So the guys, after computation's advent, the experts of computation like Mark Burry, sitting in Australia, him and his team took up this challenge to reverse engineer these things. So they salvaged the whatever broken prototypes or whatever data in terms of drawings or documents they found, and they started creating digital model of it, which is what you see on your right side. And next, please. So on your left is the physical model, and on your right are the screenshots of digital model. So they scanned it, they tried to generate the geometry, they did all these exercises, and after that, they created this digital data, which then they sent it back to Spain to the stone quarries. And again, those stone quarry guys had knowledge enough to read the three-dimensional data, and they started producing it using CNC machines. And after that, we see whatever the backside of the Sagrada Familia getting completed, as much as it is done now, and it is still under construction. So these are the the examples of how and what's going in the geometry, physical, digital, etc. Next, please. After this, I am showing a few examples of various buildings changing scale from a small sort of serpentine gallery to a full-fledged building and various approaches. So this is just to show you a panoramic view of what is possible and what has been done. Many of you can follow these things in coming time. So that's 2002. It's a serpentine gallery project done by Arup and Toyoito. This was working on the algorithm of reflection analysis, right? So it's very simple. Simple principle in physics which says that if you have an arrow, like an array of incidents, it will reflect on the surfaces. Now these diagrams show that this will happen in 2D, and if it's repeated, it will have its own pattern. And what happens if it is done in all the surfaces? And this is one of the most simplistic example which shows that only a simple algorithm can give you a geometry like this, right? And then you can choose what's solid, what's opaque, what's transparent, and it would have its own reasons. So please do read about the projects what I am showing you, and don't go just with the pictures, because I hate it when people just see the pictures and make assumptions in their mind, and when discussed, you don't even know the inherent logic about it. So please, I have a request to all of you that whatever you search on Google, go a step ahead, looking at the images, whatever interests you, read about it. Read about it, because it always has a lot of logic behind it. So then from there, as a diagram which looks like very chaotic, no design ki acha kuch nikal aaya, to let's build it. It's not like that. That went through, these are the structure analysis diagrams. So if you had that, what happens to all those red and blue and yellow members? Those are actually beams. And what happens if you have an opening this big, or if you have an opening this big, and what is the... So that is precisely showing you this associative modeling. That if you change something, your structure analysis will automatically follow, and you have that inherent data with you. Next, please. And then from there, this is a slide which shows the fabrication drawings. So from the same model, if you continue in the same environment, you are able to extract information for production. तुमने उसमें से ग्लास का साइज निकाल के ग्लास वाले को दे दिया, बीम का साइज निकाल के fabricator को दे दिया, and then so on and so forth, right? So you have the whole information ready at your single point contact. Next. That's another project. Zaha Hadid. I believe all of you know it. I don't want to ask whether you know it or not. That's in Rome. Beautiful museum. They designed based on the fluid dynamics as principle. So you see, suddenly various principles of physics, biology, nature, biomimicry, all of this keeps coming in the picture, which when you sit and design, traditionally sometimes you don't consciously do that. You are stuck with your program as 2 BHK, 3 BHK, or whatever is the program and function of the building. Now you say form follows function. That's what you produce. And I say you have to change the logic in the current scenario, because enough of it as form follows function. Form has its own function to cater. So I would rather be vouching for such beautiful experiences, because these are the building that changes completely your perception of a building itself. And if you go through the spaces, it really does a magic to you, and it's no more like you are in a box anymore. So next, please. So you see that the logic of fluid dynamics is not only followed in plan or plan generation, or it's not only showing you 3D, it's continued till the last detail of interiors and furniture. And even if you then go and see even a door handle or something, you are able to continue the same language till the last detail. And I don't see this any different from what Corbusier has done or Kahn has done or Alto has done. Even the modernists were appreciated for their work to a large extent because they had a vision and they carried that vision till the last detail. And it's the same thing. It's just that the generation of it changes the whole experience. Next, please. And yes, it's not coming cheap and it's not coming effortless. So to make that kind of building, you need a humongous workforce, you need resource, and you need money. If somebody says it's coming cheap, I think it's foolish. And you are yourself. It's not coming cheap. And my dear Frank Gehry. So that's another approach. You would all, you're all smart, so I'm happy. So that's third sort of approach where you are designing something using, again, physical material, digital material. And when you are dealing with something like concert hall, you are also taking care absolute about sound. So you have to take care of reflection, absorption, sound, this, that. The biggest example we all know of modernist is eventually Sydney Opera House by Jonathan, right? After that, we started seeing these kind of opera house. So not that only the outer geometry is driven by computation, till the last detail, as I said, performance, function, beauty, aesthetics, everything is integrated. And last but not the least, talks about sustainability. We can get there, but again, a separate subject that we have to deal with, how sustainability can be achieved through computation, because it is possible and it has been done. So, as I said, again, this is the kind of building information model they had made. So what you see here is the model that they had given to fabricators, and then that's what is the result. Next, please. That's the central ceiling of the central auditorium, like the opera house. And these are the drawings of external cladding, titanium cladding panels and its structure. So when you have a precise sort of data like this, then only you can produce things like that. Otherwise, bathroom में tiles का last residue आता है, because जो आएगा वो आएगा. It's a residual tile. Here we're not talking about any residues, because they can't be residues. And this particular image also shows how many pipes and how many things are going on to make it cooler or warmer, or with the change of climate. क्या चाहिएगा आपको? So that's the example of building information model we are talking about. That you have, for such complex buildings, you have all the data in single source. Now, way opposite to this, we're talking about Fosters, who are known for their sustainability agenda. And I have great respect for all of them that I've presented. That's why I've put them here. So this does not talk about any complex geometry, right? It's rather the most simplest geometry that you are talking about, a pebble, a stone, which is found in nature. And that's being built as the most important building of the city, because it's corporations standing there. What have they done? This was one of the initial projects. If you read the year, I'm sure you know when. Yeah, this is like in 2001 to 10 wala time hai ye. So in those days that this was done. So what have they done is they have really designed this geometry, literally inspired from a pebble, and then optimized it to the level that each window of this is responding to the sun ray, and how much heat can it control, because in the colder climate you need heat when it's needed, and you have to reduce it when it's not needed type. So how much can you optimize? And of course, as a pebble, you would want to have all these really smooth, no, because pebble surface is absolutely smooth. But it also shows an example of how can you optimize the cost. Because if you have curved glass, double curved glass, it's going to cost you a lot. However, they have put it here in triangulation, certain frames. But this side, they are all paneled straight. They are wedge shaped, but they are not curved. So it has done its job. Next, please. So those are the simulations of sun, sort of thermal simulations. There is also this which is done for the sound inside, because it's like an atrium of multiple floors. So if you are standing down and shouting, it shouldn't reach the top floor. So there are sound simulations done. And of course, I think because of the PDF, the videos don't run. Go next, please. But yeah, some of these really are enlightening. How can you use these optimization, or rather these are generative models of how you can work with sound or sun as climatic aspect to generate your designs. And then the optimization. So these are the strings of glass panels, which were directly then extracted and numbered and sent it to fabrication and then put back. One of the last project as pictography is this. Now this is airport. So if you recollect, the scale is slowly increasing and complexity is also increasing. And the approaches are varying. This one does not talk about any sort of logic which is algorithmic, or it is climatic, or it is acoustics or nothing. This is pure origami, and it talks about the context where it is coming from. Japanese are experts in origami. So this comes from the origami logic, and if you move the slides quickly down, there's nothing to explain in this. It's there. But then how do you convert this little paper craft to such a scale? Without computation, I don't think this was possible. Next, please. And then the examples like this, where we are talking about double curved surfaces and large spans. Milan Trade Fair requires large spans. So there are areas and arenas which requires really large span, column-free spaces, and then they are designed. So it's like that. I think there are some references I have collected, and before I end, you can open the website. So that's all about logic. What's the time? So we are running out of time. 3 minutes over. But not just talking about all these great architects. We do some work which you guys can see on our website. And we do take up commissions, like I said in the beginning, where the scales are not a restriction. Like we are not really following any typology, commercial, residential, hospitality, this, that, nothing. What we want to do is we want to take up every project which has an exploration of computation, little or bigger. So anything that we have spoken here right now, you will find a project which is, I think one of that is displayed here, which is like a full bus, BRT kind of bus depot and control center. So it's a full-fledged architecture project, which we were associate architect to Arya Architects. There's another project, large scale like that, where we were also associate or sort of specialist consultant to larger architecture firms, where we come as a specialist or a consultant, like engineers come as consultant for the special role to play, which overall project is laid by an architect, and then you come in to do the special part of it. Likewise, we have done this Hubli interchange station and mushroom columns there. So having said that, I just say a little bit that the mushroom columns that you see at Mumbai airport, which is like known to everybody, we've done something similar as columns, 13 meters by 5.5 meters span each column, and there are 50 of them in space. The bigger difference is that we have done the structural columns and not like false ceiling which you see in the Mumbai airport. Mumbai airport has mushroom columns which are actually false ceiling. The roof above it is doing something else. Here the entire structure or the roof is held by these mushroom columns, and there is no other skin. So that's another thing we like to do as office, as it's my personal passion, that you always design with the line of force of structure and get closer to nature as much as you can. And other than that, we have done a few projects at interior design level, that we have done various lounges and special projects, or we have done sculptures like kinetic sculptures. We've done 2 of them, one in Amul Dairy Anand and the other on the Atal Bridge. So maybe I don't know how many of you have seen Atal Bridge or gone, but the one in the center, which is wind powered, is done by us. Any questions, or do we have time to question? Okay, all yours.
Yeah, so I'm currently a final year architecture student at Samruddhi. I'm in Nirma University, Institute of Architecture. So it's my final year going on right now. So at this point, I think I can speak for many and most of my batchmates. I mean, we've just done our bachelor's, and most of us, we have a very basic understanding of parametric and associative modeling now. But yeah, so we have a very basic understanding. We know Rhino and relevant tools to a very limited level. But then what would you recommend to people who are looking to go further into computational design and to a certain level of complexity that you've spoken about? So what would you recommend to people like us who very basic, we're just starting out? So what would be a first step?
I think all those who are genuinely interested, even 1%, my strong recommendation is that understand that this path is not easy. It's not going to be coming with a lot of ease and money and all of it, because the acceptability level, or let's say market level, or whatever in the profession defined, is very, very low still. People who understand this very well, genuinely, are few in numbers. And like Rajesh yesterday spoke, if somebody was here, that you are speaking a language which only architects understand. And your client is never going to be fellow architect, except that you are working like me. I work with many bigger firms of the country, that they want to do some special part in their project that you can contribute to. That's the only architect forum that you will be dealing with. So if you are dealing with direct clients, yes, the builder lobby would want to do this very aggressively. But the moment they come to know that there is a cost involved in it, it drops. Because this doesn't come cheap. Builder lobby, I am saying why they want to do it, because they are under pressure to deliver new every day. Not the client, not the architects. And that is contributing to the biggest part of construction industry. The builders, real estate guys. But then they want to do everything in a limited cost. Or sometimes they only will come to you for cost optimization, where you can work, but that's not your interest then, that every time you don't want to get into cost optimization, right? You want to say that what value does it add, and then I will optimize the cost. At least that's how I see it, that what is the value addition of this whole thing in the project. Hence, I am proposing it, and hence I am able to convince the client that this is the value addition. This is something you will not see anywhere else. And if you are urging for such thing, but then it doesn't come cheap. It has its own quality, it has its own cost, and it will take its own time. So if you want something quick, if you want something cheap, this is not the way to go. Then better go for mass production. That's the ideal way of doing it, because it comes quick and cheap, and it has its own strength. So there are two opposites here. So you want to pursue it. First, make up your mind. Second, gain some experience, I would say, at offices or people who are pursuing this full time. Second, if you want to pursue masters in this, in an open forum like this, I am saying, but unfortunately, none of our schools in India is teaching this to the depth that is required. What we are teaching in our country doesn't follow a genuine curriculum yet. Everybody is surface scratching. आप जाओगे masters में, you're laser cutting, 3D printing, this, that, and in the end, robots. Why are you doing it? When are you doing it? What will you do with it? Nobody is teaching. So, if you want to pursue masters, and if you are able to afford, go to university, those who are doing it genuinely. And I have nothing against the university in India and people who are teaching here, but somehow we have not come to the level of curriculum which really teaches in depth these things. And then after pursuing masters, what's your way forward? Again, the question, like I am teaching a master studio at CEPT, and I asked these students, I asked first day, I said, what's your way forward? What are you pursuing this specialization for? Masters करने के बाद तो your path changes, no? If you are working in an office for 2 years and you didn't like it, you can jump. Third year mein you are somewhere else. But after pursuing a full-time master's, if you want to come back to architecture, that means your 2 years of time, energy, fees, everything is wasted. So why should you do that? So my genuine advice is that do it, pursue it, but do it thoughtfully, consciously, and make your decisions accordingly. Sorry about the class, but it's a pity, because I have seen curriculum of many schools, and I've known, I only see some explorations. So now, itni baar I have heard explorations, that I feel scared about this word. On the name of exploration, you just can't do anything and waste material, waste your time, waste your energy. The second thing we say is experimentation. Experimentation without any aim is useless. If you don't have any aim, if these guys didn't have any aim for the project, it would have been useless. Who would have appreciated it? So you say, okay, I scribbled and I made these experimentations and explorations, but then what? What is it doing? You can do that like you did in foundation studio 1 year or 1 semester, where you have learned the alphabets, scribbled. But uske baad to you have to get serious about it, no? You have to do 5 projects with it, then you will come to know that where and how can it be applied. Knowing Rhino and Grasshopper as basics is very good, but it's just a start. What can you do with it? And is Rhino and Grasshopper the only way to pursue this? Because sometimes I'm also coming across a lot of students and younger, fresh graduates or master. Computation is equal to Rhino and Grasshopper. I know these things, so I should be able to do great, no? Think about it. I'm not saying anything is right or wrong or black and white, but think about it. I want that at the end of this lecture, it should make you thinking human beings, and it should make you question what, why, how. And if you read 5 articles, read genuine source books, I'll be happy. Thank you. If there is any other question. You've raised a good question, only messed up with my mushroom column and mycelium column, but that's totally fine. Again, when I mentioned or started this presentation, you might want to change this screen to. So materiality also comes as an input while generating your designs. And hence you are not limited to traditional reinforced concrete as a material. Right, you could start with brick, you could start with XYZ material. And there is a whole branch of material science which has developed around digital fabrication to cater to these kind of innovations for sustainability. Short answer is that if you're genuinely interested, go to CAADRIA 2022, which was in Australia. Ours was 23, theirs was 22, and the whole topic of the conference was sustainability. In Australia and in countries like Netherlands or places which are really prone to climate change, northern polar countries, that they are facing climate change now on a daily basis. For us, it is just about heat. And we are still saying just, we are not serious about it. When I am talking also, we are saying we are facing so much heat. All we are doing is put more air conditions. Whereas those guys, when they did this conference, so you will find at least 400 papers in that conference proceedings, which is talking about sustainability and sustainability through material, sustainability through production methods, sustainability through design, computation, and so on. And they have reached to the level where the government and education and research, and they are all on the same page. So the decision making is on their side now. That okay, if you want to address these issues, this is the urgency, and you will be able to resolve this quicker if you go on this path. So there is a lot of work done in that direction, which is published. You wanted to ask?
First of all, I would like to say that this presentation actually is a very good, well put and concise way of going about the whole thing, because each slide in itself is a very huge topic. So I am a computational designer working in Ahmedabad. So so when I was in college, I was researching all of it, at how it came about, computation, and how it flowed through, very early experimentations by John Fraser, the evolutionary architecture, his whole idea. So particularly about your practice and the project that is displayed here, I believe the process was that a conceptual model was designed by Arya, and what you did was rationalization of that whole form and optimized. Wasn't that okay? So about the roof form. Yes, thank you.
So, but yes, what you said could be a workflow which happened to us in Hubli, where the planning was laid, and there were columns also placed. Of course, then they had also designed a certain column which could span 13 meters by 5.5 meters. So it would have worked. We then played a role only in replacing those columns with mushroom columns, which were structurally stable without any separate skin, and other. So it just added value to the project, that okay, instead of standard columns that it's concrete and then there were 4 members, like it can be done with a fabricated structure. We did something more beautiful and it's been celebrated. So that was the case in the next project that we had. Anybody else? Thank you so much for listening to me peacefully. And thank you so much for good questions. Thanks. And thank you, Elev8, for this opportunity. Of course, none of it would have happened if you didn't give us this opportunity. Thank you so much.